In this video, we're going to review how we calculate our summary statistics. We're going to have 4 different statistics that we calculate. The first 3 we're going to have a look at are the mean, mode, and median. These are 3 different ways that we can measure the centre of our data. So we call these measures of centre. So let's define these first. The mean is a common one that we use. It's also known as the average. And to calculate the mean or the average, we sum up all of our scores or data points, find the total, and divide that by the number of scores involved. We hope that this score gives us approximately where the centre of our data is using the values. The mode is the most commonly occurring score. This is where we see repetition in some values. Now, there's no actual calculation that's taken place here, it's just an observation of a score that occurs more than once. Sometimes we can have more than one mode. So if we have 2 modes, 2 numbers that occur the same amount of times, we call this bimodal. But if we start having 3 numbers that come up the most, 4 numbers in our data set, then we suggest that there is no mode because there are just so many scores that are common. Now the median involves sometimes a calculation, but it actually represents position. It is in fact the middle score when our scores are placed in ascending order. And ascending means smallest to largest. So this one's very much about the position of scores. What score is sitting in the middle position when we put them in order? Our other statistic, the range, doesn't measure the centre. What it measures is the spread of our data. How spread out are our scores? This is a calculation, and we find this by taking the highest score and subtracting the lowest score from it. So it's not 2 values that we state, it's a single value in a calculation. So let's see these in action. So in my first example, we have the time in minutes taken for some people to complete a crossword puzzle. Now before I jump in and calculate the statistics, I'm just going to have a look through these values, and I can see they're all fairly similar. And I'm going to identify my minimum and maximum first of all. You can see my smallest value here is 15, and my largest value I can see is 45. So that's good to identify straight away. The other thing I'm going to identify is the number of scores that I've got is 11, an odd number of scores. So to calculate the mean, I'm going to sum up all of these scores. So when I add them all up, I get 350. I'm going to divide that by the number of scores. What this means is we're going to find the average. We're going to share out that 350 total equally among the 11 people. And this gives me an average of 31.8 minutes, approximately 2 minutes. Now the mode is the score that occurs the most, and if we have a look through, I can see that the score of 24 minutes occurs twice and no others are repeated. So my mode is 24 minutes. We notice this is quite different to our average because our average is actually a calculation, whereas our mode is just an observation of a score that occurs more than once. So in this case, I'd probably lean more to the mean or the average as a way of finding the centre. Now the median is putting all of those numbers in order. So I'm just going to reorder them at the top, writing them underneath the original one so I know that I don't exclude any of those 11 and I make sure I have them all. Writing them in ascending order from smallest to largest. So to find this median, this middle score, there's a couple of ways that we can go about this. The first one is simply just counting in from each end until we arrive at that centre score. And it falls on 35. So that tells me the median is 35 minutes to complete the crossword puzzle. That's the middle position. Another way we can do this is to understand that because we have an odd number of scores, that we are going to fall on a score when we find a middle position. And we can simply do this by saying, okay, we've got an odd number of scores, so half of 11 is going to be 5.5, so we're going to go to the 6th number. Now we've got our 3 M's, our 3 measures of centre. We can see here that they're all fairly different. So our mean and our median are much more similar, being about 32 and 35 minutes, but our mode is quite different. So that's one of the first summaries we can make, is the mean and median are similar, whereas the mode is quite different. Let's have a look now at our range. Our range is our highest score, 45, take our lowest score, and that's going to give us the range of minutes between the fastest person to complete the puzzle and the slowest person to complete the puzzle. You can see that we've got a difference of 30 minutes, so quite a difference here. And that's another observation or a summary that we can take. We have quite a large range of 30 minutes where we have an average of approximately 32 minutes to complete the puzzle. So we can certainly see that there is a big difference. So now I'd like you to pause the video and have a go at the next question, having a look at the heights of some Year 11 students. Unpause the video to come and check your solutions. So from your results, we can see that the measures of centre, the mean, median and mode, are all quite similar, around 170 to 173 centimetres, with an average height of about 172.5. We do notice that we still have quite a large range from the shortest to the tallest person in Year 11 that we've surveyed, being 40 centimetres. So in our second example, we've got a table that shows the game scores of 10 friends who are playing a computer game. So having a look at these 10 friends and scanning their results, you might notice that something sticks out, and that's Peter's result. Obviously, he's very good at getting a high score in this game. So because we've got just some discrete numerical data here, we can go ahead and calculate the statistics because they're numbers that we've collected. So we can see that we've got a mean here of 44.4 as a score. We have a mode of 46. We can see that Albert and Martin both scored 46. What we also can find is that we have a median of 41. Now, because we've got 10 scores, when we pop these scores in order, so I'm just going to rewrite them. Obviously, Peter's at 93. Our next highest are the two boys with 46. We have a 45. We have a 44. Then we go into the 30s. We've got a 38, a 37, a 35, a 31, and a 29. So when we've got an even number of scores, which is 10 scores, the middle number is going to fall in between two scores. So what we're trying to do is chop that exactly in half, and so 10 divided by 2 is 5. So if we go 5 scores in either side, we actually fall in between 38 and 44. So halfway between 38 and 44 is 41. Now our range, the highest score at Peter of 93, take the smallest score of 29, leaves a huge range of 64. So to me, that's quite alarming to have a difference of 64 points in a game. So what this tells us is because Peter has an unusually high score, we would say that he is an outlier at 93. There is a huge difference between Martin and John at 46 and Peter at 93. So we would call Peter an outlier. An outlier is where he lies outside the rest of the data. So by taking out this one outlier, it'd be interesting to calculate the statistics and see how they change. When we recalculate, we end up with a mean of 351 over 9, which leaves us with an average of 39, which is a lot lower than 44.4. Our median falls to 38. Our mode doesn't change because we're not getting rid of a common score, otherwise it wouldn't be an outlier. And our range is now going to be 46 take 29, which is just 17, a huge difference from a range of 64. So we can see by having one extremely high score, it's really changed our statistics. We can see that our mean and our median have both decreased, particularly our mean. And our range has had a large decrease. So now it's your turn to examine some data where there is an outlier. So I'd like you to pause the video again and have a look at the information about some students running the 100-metre race, given times in seconds. Have a look at the extreme score or the outlier, and then take that outlier out and have a look what's going to happen to those statistics. Then you can come back and check your solutions. So in this question, what we can notice straight away is that we have Frank as an outlier. He has a higher time, so he's a lot slower in his running of 100 metres. And this greatly affects our range. That originally has a 7.2 second difference, but as soon as we take Frank out of it, the statistics drastically reduce, where the other runners have very close times with a range of only 1.7 seconds. When we exclude an outlier, we'll see a change in our mean and in our median.